In this video, we're going to talk about what a function is and how to find domain and range. So before we talk about what a function is, we need to just go over what a general relation is. And a relation is just a rule that associates an x value to a y value or multiple y values. So we've been working with relations since elementary school. So here's an example of a relation. So what this says is when x is 0, y is 0. When x is 3, y is 30. When x is 2, y is 20, and so on. So here, a relation could also be, instead of just a set of points, it could be in a t-table. So here, when instead of x, we have the number of lawns. So when someone has mowed one lawn, they've made $10, and 4 lawns, $40. So we've got an x, and it's related to one or more y's. Or we could be given an equation. This is another rule. This says that when we input an x, it gets multiplied by 10, and that's how we get y. Or we could see it in a graph. So we can pull out each of these points and find out when x is 2, for example, y is, it looks like -2, etc., etc. A function is a very specific type of relation, and the rule is that there's only one value of the dependent variable for each value of the independent variable. If you have no idea what that means, that's understandable. In English, what that really means is that every time you plug in an x value, you only get one y. So in this definition, we called y the dependent variable because in a relation, we don't always have x and y. So for example, we have here lawns and revenue. So when I'm talking about x, I'm really talking about the independent variable. When I'm talking about y, I'm talking about the dependent. So let's go over that definition again. A function is when every time we plug in an x, you only get one y. And you might be thinking, well, that's majority of the relations I can think of. So for example here, if I plug in an x, so let's say 1, I'm going to get out 10. And if I plug in a 2, I'm going to get out 20. So every time I plug in an x, I only get one y. So this would be a function. But here's some examples of things that are not functions as well. I'm going to highlight it one more time just because we're going to keep going back to it. Every time we plug in an x, we get only one y. We're going to say that over and over and over again. Put in an x, only one y. So I have here lists of functions and non-functions. So let's just really quickly realize why this is a function. Every time we plug in an x, we should only get one y. So when I plug in a 4, I get 12. Beautiful. So there shouldn't be any other points here where it should say 4 and then we get another y. But look, there's no 4. There's no other 4. So the rule is you plug in 4, you get 12. You plug in 5, you get 15. You plug in 6, you get 18. So this follows the rule that this is a function. And it's a function because every single x value only has one y value. Look over here. Let's take a look. The rule is, in this relation, when I plug in a 4, I get 12. So we know that this first guy is our x, this is our y. So this rule says when I plug in a 4, I get 12. But it also says when I plug in a 4, I could also get 15. So automatically, this makes this not a function. Let's just go back to the definition. Every time we plug in an x, we only get one y. So automatically, I plug in a 4, I get two different y's, 12 and 15. That didn't happen over here. 4 never repeated. So it's immediately not a function. Even down here, look at this. The rule is I plug in a 5, I get 18. All right, but look, next point. I plug in a 5, I could also get 21. So this point, or these points here also prove that this relation is not a function. So that's how we can tell if something's a function or not from points. We're just looking for repeating x's. We're going to see if it gives us two or more different y values. So then it's automatically going to break the rule. How about with a graph? So this is an example of a function. This is an example of not a function, but y. Go back to the definition again. Every time we plug in an x, we get only one y. So let's try plugging in a bunch of different x's. We can see that this is a parabola. This one is a screenshot from Desmos. So Desmos doesn't do arrows, so let's just assume that these are going to go on and on forever. If a graph just goes all the way to the edge of if a relation goes all the way to the edge of a picture, you can just assume that there's arrows there, unless there's like a big dot to show you that's done. So anyways, why is this one a function? Every single x should only have one y. So what I like to do here is I like to draw lines. So I asked myself, when x is, let's say, let's pick one in the middle, 3. How many y's do I get? Well, I don't have any y's up here because I don't hit the relation, but I have a y down here. Boom. So this is the only point here. So when x is 3, I get a y value of -2. I don't hit the relation again. So this x only has one y. How about another x? Let's try 4. I'm going to plug 4 into this relation. What do I get? Well, I don't hit the function up here, so I don't get any y's there. Boom! I hit y right there. That looks like it's about -1 or so. So when I plug in 4, I get -1. How about another one? Let's try 6. When I plug in 6, if I go down here, it's not going to hit the relation. I have to go up, 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 up. This graph continues, so it's going to hit, x is going to be 6, maybe somewhere up there, and it's only going to give me 1 y. So every time that I check an x value, it only hit the relation one time, so that's why it's a function. Every x value has only one y value. So let's take a look over here. Why is this one not a function? Well, let's just plug in a number again. Let's plug in 2. So I'm going to go down here. Okay, it doesn't hit the relation. Let's go up here. Oh, I hit the relation here, and I hit the relation here. So if I plug in x is 2, I get the answer of 1. I get a y value of 1, and I get a y value of 5. So go back to the definition. Every time I plug in an x, I should only get one y, but here I get 2. I plug in a 2, and I get this y value, which is 1, and I get this y value, which is 5. So automatically this fails the function test. This is not a function. Let's try a different number. What about 4? If I plug in 4 into this relation down here, it doesn't hit the relation at all, but it hits it here at, it looks like 0.5, and then I keep going up, 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 and it also hits it here at about 5.5. So when I plug in a 4, I get, which is our x value, I get two different y values. I get 0.5 and 3 and 5.5. So our conclusion is that this guy is also not a function, because when we plug in an x, we get more than one y. Let's try another example. All right, we've got 2 more graphs here. This tells us it's in the function line or column here. This is not a function, but y. For this graph, let me teach you a shortcut. A shortcut is called the vertical line test. The vertical line test says that you can really quickly tell if something's a function just by drawing a vertical line. And if in that vertical line you hit the relation more than once, it's not a function. And if you only hit the relation once every time you draw a vertical line, it is a function. So I'm going to say that again. I'm actually going to use this example that we have on the other page. The vertical line test says that as we draw lines, if we only hit the relation once, it's a function. But if we hit it more than once, it's not a function. So for example here, really we're drawing vertical lines. We're just checking for every x how many y's there are. And as I do this one, it hits the relation 2 times. So that's not a function. Here, it doesn't matter where I draw straight lines. I only hit the relation one time, one time, one time. So it is a function. So let's try that shortcut on these 2 graphs here. So if I draw a line along this graph here, I only hit the relation one time. So this is a function. And it's a function because it passes the vertical line test. Every x has only one y. How about this guy? Well, if I drew a line just here, then it only hits it once. But the vertical line test says if it fails it anywhere, it's automatically not a function. But here, you can see that when x is -1, it hits the relation more than once. Same with here, same with here, same with here. So this is not a function. And it's not a function because it fails the vertical line test, VLT, vertical line test. How about this one? Would this pass the vertical line test? Does every single x only have one y? Let's take a look at this one. And when x is -2, it only hits the relation here. So this relation is a continuous relation. It's called discrete. It's just made up of individual points that don't connect. How about this guy here? When x is -1, only hits it once, 0 hits it once, 1 hits it once, 2 hits it once. That's it. So what does this mean? It means it's a function because every x only has one y. And what about the one to the right? It's in the non-functions column, but why? Where does it fail? Well, take a look at here. Look at where 4 is. When I plug in x is equal to 4, I get two answers. I get y is equal to 14 and y is equal to 16. And the definition of a function is when you plug in an x, you should only get one y. So here is where it fails. So let's do a couple examples. We're asked to figure out whether these relations are functions or not. So if you're taking a look at this first thing and saying, what the heck is that? This is called a mapping diagram. So it's just another way to represent points. So how to read this is the first bubble is the independent variable. So usually we call that x. And the second bubble is the dependent variable. Usually we call that y. So what all this says is that in this relation, when you plug in a 1, you get a 6. When you plug in a 2, you get a 6. When you plug in a 3, you get a 5. 4 is you get a 4, and 5 a 4. So just this one time, I'm going to translate these to points, just to make sure you understand. So here they are in our sort of coordinates that we're used to. So when I plug in 1, I get a 6. That's what this point is. When I plug in a 2, I get a 6. There's this guy. 3, I get a 5. 4, I get a 4, and 5, I get a 4. So what's the definition of a function? Every time I plug in an x, I should only get one y. So when I plug in a 1, do I get more than one y? Nope, I just get 6. How about 2? Do I get more than one y? Nope, I also just get 6. The y's can repeat, but the x's can't. When I plug in a 3, I just get a 5, only one number. When I plug in a 4, I only get a 4. When I plug in a 5, I also get that same 4, but y's can repeat, x's can't. So as long as every time I plug in an x, I only get one y, it's a function. So to conclude, this guy is a function because every x has only one y. How about this one? So this is another mapping diagram. So we can always assume in a mapping diagram that the first circle represents our independent variable, so that's typically x, and the second oval there always represents our dependent variable, which we typically call y. So this says when I plug in negative 35 for x, I get 1. So far, so good. But look at this arrow here. This says when I plug in negative 35, I also get 22. Automatically, we failed. When I plug in negative 35, I get a 1, and I also get a 22. By definition, this is not a function because I'm plugging in one x and I'm getting multiple y's. If you need to see it as coordinate points, here they are. When I plug in negative 35, I get a 1. That's what this is saying. When I plug in a negative 35, I also get, oh, sorry, I put 4. It should be 22. Let me just erase that. I don't get a 4. I get a 22. Okay, there we go. So let's go over that again. When I plug in a 35, negative 35, I get 1. And when I plug in negative 35, I also get 22. That's what this shows. So automatically, this is not a function because here, it fails right here. 1x gives me multiple y's. The x value of negative 35 is associated with 2 y's, therefore not a function. What about a graph? This we're familiar with. Is this a function or not? Well, let's do our shortcut, which is the vertical line test. If I draw vertical lines and only hit the relation once, it's a function. If not, it's not a function. Here we go, one vertical line, and immediately it hits the relation more than one time. It hits it here 1, 2, 3, 4, 5 times. This is definitely not a function. And the explanation is just the same over and over again. It's not a function because each x value gives multiple y values. I plug in this x value, whatever it is, I get 1, 2, 3, 4, 5 different y values. And how about this guy? Well, this is just points, right? Just like this. It's just a different way to write points, which is in a t-table. So is this a function? Every x should only have one y. 0 has 0. 1 has 4, 2. I can already immediately tell this is a function because none of the x values repeat. So it's not like 3 is giving us 6 and another number. Well, there's no other 3 here. So if these guys aren't repeating, then this is definitely a function. Every x only has one y. So when you try problems about whether something's a function or not on your own, just always go back to the definition that every x only has one y.